So for this question 1, show that this is a factor. This x minus 3 is a factor for this polynomial, hence factorize completely. So how to show? So when we do the question of show or verify something or proving something, it is very important our working written clearly. So if we get this x minus t is said is a factor, means our working we need to do is using our factor theorem. We will start substitute our x into the polynomial, and then we have to calculate until we get 0. So it's not directly equals to 0. If you put directly equals to 0, means we are using the theorem, we are not showing. Therefore, our correct way will be showing our x value is 3, then we substitute the value 3 into the polynomial. So here we don't put 0. Once we put 0 means we use this concept. We are not proving this concept. We are not showing. The question asks us to show. Means for this moment we still not sure is it equals to 0 or not. So we have to show our calculation until we can get it 0. So after we substitute, you'll notice that we show it one by one. So this calculation will bring us to 0. So this is what we mean here. So when it equals to 0, then only we can come up to the conclusion. This bracket x minus 3 is a factor of our polynomial px. So this is how we show something. So we have to see here, substitute the value into the polynomial, get into the 0, and then do the conclusion. So it will be different when we applying and when we showing. So applying the concept, we can see if we are applying concept directly equals to 0. Directly equals to the numbers. So after we show this, we are going to factorize it completely. So we can see our polynomial in cubic. So I want to find other factors. We have to do our long division, divide by this one of these factor. So we supposedly will have 3 factors together because this is cubic polynomial. So therefore we take our polynomial here, arrange in order. After power 3, continue with power 2, continue with x, continue with numbers, and then divide by factors, one of the factor here, to find out other factors. So what should we put here? What's the multiplier? We need a x squared. So that when we multiply in, we can fully divided x cubed. So we don't have any x cubed anymore. Then we minus here, we'll get x squared minus 5x plus 6. So we continue. So we time a x in order to get x squared. Our multiplier here is x, so x squared. Then continue expand for the negative 3. And we minus. So you'll notice that every time our long division, we must able to finish divide our first term here. So when minus 0, then we minus here, we will leave positive 3. So it will give us negative 2x plus 6. So we times the negative 2. So we don't have any remainder. So this is our factors. Therefore, our polynomial is equals to x minus 3. Another factor here is x squared plus x minus 2. So factorize it completely means for the quadratic part, we also need to factorize. So we can press the calculator to find out a equals to 1, b equals to 1, c equals to negative 2. What is our roots? From the roots, we find our factor. It will be equals to 1 and 2. So negative 2 become positive 2, equals to 1, it become minus. So you can notice that every time we want to factorize completely, we need our long division. Then only we can get our factors. So I have to write it clearly this. So this is 3, yeah? Yes, write it clearly. Yeah, correct. So this one is 15. Continue for the part B here. They say uh, a polynomial, a quadratic. So they want to use fx, then depends on the question on how they want to label. So this polynomial fx is a quadratic. It leaves 1, 25, 1 on the division of these three. So means reminder theorem lah. Reminder theorem. We have three reminder theorem here. Divide by three different divisor, and then find the value of A, B, C. So notice that they ask us to find three simultaneous equations because this is three unknown. So we were going to solve three simultaneous equations. After that, we're going to show that this function just it has two equal roots. Okay, so we have to build out this first. So for the first one, when x equals to x minus 1, means x will equals to 1. The remainder is 1. So f1 equals to 1. So this is our first information. So accordingly to the second divisor here means this is its remainder. When x equals to negative 1, f negative 1 will equals to remainder 25. And the third divisor here, x negative 2, x minus 2, so x equals to 2. When we substitute into our polynomial, the remainder is equal to 1. Okay, so we have three information. Then we build out our three simultaneous equations. Substitute 1 inside our fx, we become a plus b plus c equals to 1. Then substitute negative 1, we still have a, but this is negative b plus c equals to 25. Then substitute 2. 2 inside will become 4 plus 2b plus c equals to 1. So how we going to solve this simultaneous equation? We find something that are similar. We can find something that are similar. We can eliminate it first. Then kita akan dapat the remaining unknown. So you boleh nampak ini ada ABC, ini ada ABC, ini pun ada ABC. So boleh nampak dua equation ni. So this is our first one. This is our second one. This is our third one. So kita boleh nampak apa yang sama. Kita boleh nampak A, C sama. AC sama dalam equation 1 dan 2. Means that we can operate these two equations first. We operate these two equations first. We eliminate our AC, we can get B. So from here, we can do 1 minus 2. So therefore, A minus A will be finished, C minus C will be finished, and then B minus negative will become positive B. So you get 2B. And then 1 minus 25, you get you negative 24. So B will equals to negative 12. So we managed to solve one of the unknown, which is B. Then we continue to find A and C. So when we want to find our A and C, we will select two more equations. Because these two equations are similar, so we will choose either one of it to build up our equation in terms of A and C. So from here, I will choose this one. We will use equation 1, substitute our B here. So our latest equation here, the latest status. So from 1, substitute our B equals to negative 12. So our latest equation A plus C will equals to 13. So this is our equation 4. So from this, substitute B equals to negative 12 into 3. Then we will get 4A minus 24 plus c equals to 1. So 4a plus c equals to 25. So you can have a concept here to see when we have three unknown. So three equations. So when we solve one of these unknown, we leaving two unknown a and c. So we need to build out the equation involving a and c. So just now because we use this one similar, so means that either one of them only can build out one of the equation. Then take another different equation here to form our AC equation. So from here we can solve our AC according to the equation 4 and equation 5 here. So you have similar C. So you can see you have similar C. We can eliminate our C. We take equation 5 minus equation 4. So when 4a minus a, we get a 3a. C minus C, we eliminate. That's why we get our A. So 25 minus 13, 12. So A equals to 4. So lastly, we can substitute into either one, either 4 or 5. So I choose 4 because it seems like easier. 4 plus C equals to 13. So C will equals to 9. So this will be our first task. So start from beginning, our theorem, our reminder theorem. We have 2 marks for these 3 reminder theorems. Then build up 3 simultaneous equations, substitute our value of x. So this concept is substitute our value of x. And then try to solve our simultaneous equation for the first B answer, and then solving simultaneous equation for AC. Number A is 4, C is 9 is your answer. So therefore, finally, you will get our function. Our function now, if A is 4, so substitute back our function now. B is negative 12, so negative 12x. C is 9. So this is our function with complete ABC. Hence means use this ABC, we have to show that this function, when it equals to 0, means for this quadratic, when it equals to 0, it has 2 equal roots. So it has 2 equal roots means we can use the discriminant of the roots, b squared minus 4ac. We show that. This is our form 4 concept. You have 2 roots, so b squared minus 4ac, it will be equals to 0. So we have to show it up, means we have to have clear working. So when b squared minus 4ac equals to 0, means this quadratic function has 2 equal real roots. So this is our concept of solving the roots and get 0 to the conclusion.